Hey guys, today we are going to be talking about parametric equations. So, why are parametric equations important? They allow us to represent complex curves in a more convenient way than traditional Cartesian equations. Sometimes you'll have a curve where it's really difficult or even impossible to represent it using y equals f of x. And this is where a parametric equation could come in. Take, for instance, this curve. Pretend that a particle moves across this line. Well, we can see that it fails to pass the vertical line test. The vertical line test is a visual way to determine if a curve is a graph of a function or not. A function can only have one output, y, for each unique input, x. So instead, we can represent curves like this using two parametric equations, x equals f of t and y equals g of t, where f of t and g of t are both functions of t, where t is a parameter. The curve represented by these functions is the parametric curve. So let's try out an example. In this example, we're given two parametric equations, x equals t squared minus 2t and y equals t plus 1, and we are to sketch out the curve defined by these parametric equations. Each value of t gives us a point on the curve. So if I plug in, let's say t equals 0, and I solve the equation for x and y, then I will get the xy coordinate that I'm able to plot on my graph. In this case, there is no range that they define in the example for us for t, so I can choose my range of t values. It's a great idea to just center it around 0 for ease of calculation, and as you see the plot develop, you'll be able to add additional t points so that you can continue to sketch to see the whole picture. At this point, I'll just be plugging in points for t from -2 to 2, and you can pause the video if you want to do the calculations on your own to double check my work. To sketch this curve, we ignore the t column and we use the x and y column as our coordinate points. So the first coordinate is to go over 8 and down 1, next over 3, down 0, and so on. We continue to sketch each of the points. I decided to extend my value for t so I could continue to see what the curve looks like. Now, what's a little unique about parametric equations is that they also have a direction of motion, and this is determined by the value of t. So when t starts at its lowest value, we know that that's where our curve is starting, and then the direction continues as t increases. At this point, now that we've sketched the curve, we can see that it appears to be a parabola. This can be confirmed by eliminating the parameter t. Since we have two equations both defined by t, we can use one of them to solve for t, and then use the other one to plug our value for t into the other equation. Starting with equation number 2, y equals t plus 1, solving for t equals y minus 1, and then we plug that into our equation number 1. So that is our answer. The curve represented by the parametric equations is the parabola x equals y squared minus 4y plus 3. In conclusion, what have we learned? A pair of parametric equations, x equals f of t and y equals g of t, because they're separate equations, can help us describe curves where we can see the direction of motion. Thank you so much for watching. I hope this was helpful, and I'll see you next time.